Well, what's going on? Welcome to Team 88. This is going to be an amateur produced video. If you don't like seeing the bloopers, then get over it. This is what we have to do this year on account of we're all in the COVID world. Welcome to Team 88. I'm talking to the veteran members as well as the new students. The rookies are always welcome, and we're going to try to give you a little introduction to the team and how we do things here in the robot lab. My name is John Stewart, and I'm going to be joined here in a little while by Mr. Spur. His first name is Chief. We've got some special jobs in here. We are going to try to give you an experience that you're going to remember for a long time. I first got introduced with TJ² Robotics when Doug was a freshman quite a while ago. That was 2007. About halfway through January, I looked around and said, "Didn't we used to have a son? Where'd that boy go?" And it turned out he was over here building a robot all the time. So that's when I began to notice TJ² Robotics. I became involved in 2008, and here we are. TJ² Robotics is an experience you'll remember because it's about you having overcome a challenge, learning how to solve problems, real world problems, not simulated, not artificial, but a real problem that has a required answer. TJ² Robotics is set up so it gives you a new problem every year in the form of a game. You guys field a machine to play the game. It's rewarding because it's really hard. You cannot possibly do it by yourself. You've got to be a member of a team, and we've got quite a team here to help you out. TJ² Robotics was set up by a brilliant guy, a teacher at a school just up the road from here, who devoted his life to motivating teenagers. The guy's name was Woody Flowers. The school he taught at was MIT, and he's not with us anymore, which I regret. He passed away last year, but a lot of the members of the team got to meet him, got to talk to him, and experience some of the inspiration from Woody Flowers. Woody set it up in a simple formula. You got a problem that's too hard, a time that's too short, and a budget that's too small. Now go figure it out. Just like the rest of life, it's never easy, but that's what makes it rewarding, is you get to understand what you can do when you really put your mind to it. We're going to talk about a number of things today. We're going to talk about robotics. We're going to talk about our team and what it means to be on the team. We're going to talk a little bit about team history. Then we're going to go over shop safety, shop practices, and then we're going to summarize what we've done. Robotics. I'm not here to build a robot. I'm here to help you build a robot safely. There's a whole lot of skills involved in this, and manufacturing parts is just one of them. When we look at everything that's involved, first we got to start off with some strategic thinking. We got to figure out what is involved in playing this game, what are the important aspects, how do we accomplish it, what's more important, what's less important, and how each one of those plays off against the other. We've got manufacturing, electronics assembly, computer programming, graphic design, team management. All those things have to get involved before we have a successful season. Each one is just as important as another. There's none that are dominant. Each one has an important job to do, and we can't do it without all. We've got a lot of adults here. Remember one thing, the adults will show you anything you want to see. Seriously, just about anything. The highest compliment you can pay to one of the adults on this team is to say, "Stop. Wait a minute, back up. Show me again what you just said. I don't understand it." When they hear that, they know that you're involved. That's the best thing you can say to them. If you look around at the team that Mrs. Califf has assembled here, we've got a group of talent that's really spectacular. We've got professionals in a lot of different fields, engineers, scientists, programmers, management people. We've got qualifications that are crazy, people with bachelor's degrees, master's degrees, PhDs. The talent that's assembled here is phenomenal, and all these people are donating their time. All our sponsors are donating the funds to make this happen. Now, why is all this being donated? There's one reason. That's because they're here to give you this experience. Team membership. As a member of the team, We expect everybody to pull their share. We expect everybody to share in the work, to help out whenever possible. We expect you to help keep the shop clean. The robot lab can turn into a disaster area at the end of a build season. We've all got to share in the work in cleaning it up. When you're on the team, we expect you to help put away the tools. We expect you to help charge the batteries. We expect you to help clean up the robot room. This is part of getting the job done. We expect you to support your team members, especially if you're a veteran member. Part of what we expect from you is that you help the new members become acquainted, learn what to do, help them become a member so they can help other people. Everybody is learning. Be patient. Help the people who don't know what they're doing yet. Help keep everybody safe. All right? Be proud of what you're doing. Nobody else in this school has an experience like this. The football team, the baseball team, the band, the drama people, they all have very time-consuming activities. They're no more time-consuming than robotic. If you make something, it's up to you to make the things that you do reflect who you are. If you make something that isn't right, it's up to you to identify that, to stop and fix it, and make it right before it goes on the robot. If you put it on the robot knowing it's defective, it's only going to break sometime during a match and potentially cause us to lose a match. How well you do your job reflects who you are. If what you do is sloppy and defective, that reflects on you. If everything you do is accurate and done correctly, that's the kind of person you are. This is something you need to get your head around. Robots are serious machines. Anybody who's been around the team knows what happens to the robot when it's on the field. These things get beat up. In the Navy, we had the term damage control. This is what happens to the robot. It gets damaged, it gets beat. We have to make it strong so it can survive. We have to make it serviceable so we can fix it. This is a really serious piece of machinery. Along with that, I want you to bear in mind that the robot has to be made accurately. Everything needs to be straight and true if we're going to expect the robot to perform well. All the electronics have to be solid and dependable, otherwise we're going to get into trouble. Let me give you a thought. In school, 70 is generally thought to be passing. Well, think about that. That's like saying 30% of what you do can be wrong, and that's somehow okay. Well, wait a minute. If 30% of what you do on the robot is wrong, we haven't got a chance. Let's think about electronics. There's somewhere between 200 and 300 connections on the robot. If you work 99% accurately, that means you got 1% wrong. Out of 300 connections, 3 of them are defective. If we have 3 defective connections, they're going to fail during matches. Then something on the robot isn't going to work, and we're going to end up losing the match. So when you're building the robot, 70% is not passing. 99% is not passing. The only degree that works is 100%. Okay? That's a new rule. That's just like real life. If I'm building airplanes, is it okay if 1 out of every 100 crashes? No. People in airlines get upset if their planes keep crashing. We need to make 100% the minimum acceptable standard. Let's talk about what's in here. In here are machine tools. These are real machines that are industrial strength, industrial quality. This is not some dumbed down, simulated, artificial scenario. These are the real deal. Consequently, we have to pay attention to what's going on in there. They're strong machines, they can cut the strongest steel. Watch what you're doing. We've got a great safety record, and we're going to keep it that way. And here's how we do it. In there is a different world. The most important job in there is safety. The most important safety device is between your ears. If you stop and think, if you use your brain, you're going to be fine. When you get in trouble is when you don't use your brain. This entranceway is magic. On that side is a different world from outside. Out here, you can be a kid. You can be goofy, you can be silly, you can horse around. That's fine, out here. In there, you gotta act like a grown-up. That means you pay attention to what you're doing. In there, you got one job, and that's to operate the machine and make the part that you're making. In there, safety is everyone's job. In there, safety is the most important job. Doing the job fast, fixing the robot, those are all secondary to safety. That's the first thing we have to do. Here's some basic rules. First off, on clothing, get all the loose articles of your clothing secured. If you have a hoodie with strings hanging down, put the strings inside your shirt. Button your cuffs so there's no loose sleeves hanging. Tuck your shirt in. If you have long hair, tie it back. We don't want anything loose that can get involved with a rotating machine. PPE. In there, we wear safety glasses. There's plenty of glasses in the box right outside the door. They're mandatory inside the machine shop. To operate the machines in there, we need to have an adult with you. That's the way we do it. That's because we're responsible for your safety. I already said that in there, we're focused on the job we're doing. Consequently, your cell phone needs to stay out here. Don't be tempted to take your attention away from a running machine in order to play with your cell phone. That doesn't fly. That's just like driving a car. Driving is more important than the phone. In there, operating a machine is more important than the phone. Leave your phones outside on the table. You can catch up with that when we're done in there. Horseplay in there does not fly. If you want to see me cloud up in rain, start throwing a ball or poking each other or doing something dumb in there. That is not acceptable. Years ago, we did have 2 team members who were in there. One of them had an aluminum rod. He was sanding the end of it, working on the sanding machine, doing what he was doing. And when he got done, he had sanded quite a bit off. It was nice and hot. He thought, won't this be funny if I poke my buddy with it? So he poked him. The other guy went, yikes! And they clowned around a little bit. That got both of them suspended and a stern talking to. We do not have any horseplay in there. Now, why don't you come on in and let me demonstrate a couple of things. Okay. Suppose we have the machine running. We're drilling a hole or we're cutting something, and the piece comes out of the vise. It starts to spin around. Zing, zing, zing. What do? The first rule is don't grab it. Just back up. Collect your thoughts. Turn the machine off. Let it come to a stop. No problems. Remember, whatever you do, don't grab something that's moving. If it looks like it's going to be scary because of the thing that's flying around, you don't want to reach for the stop switch. Then there's another stop switch over here. Just push this one and it shuts down everything in the shop. No problem. Main thing is don't panic, don't grab it. You're going to make mistakes. I guarantee it. You're human, it happens. The question is not, are you going to make a mistake? Because you will. Everybody does. The question is, what are you going to do when it happens? Listen, safety is all our responsibilities. During the build season, I'm going to intentionally violate safety rules just to see if you call me on it. If you don't, then I'm going to be disappointed. If you see anybody do anything wrong, and I don't care who it is, it's everybody's job to bring it to attention so we know what's going on. And that just helps us all stay safe, all right? The main thing is learn from your mistakes, don't repeat them. If somebody you're working with makes a mistake, help them learn what went wrong and why. Help them learn how to not to repeat the mistake in the future. That's what's important. That's what teammates do. If you own up to to the mistake, then all we have to figure out is how to fix it. If you try to hide it, if you try to blame it on somebody else, then we're going to have a whole different conversation. If somebody should get injured, there's a phone over there on the wall under the clock. Just dial 911. That'll take you right to the emergency operator in Bridgewater. Tell them what happened. When you're on the phone, tell them to come around the back of the school, otherwise they're going to come to the front entrance and it'll take them longer to get here. If anything should happen and anybody gets injured, report it. No matter how minor it is, report it to the adult in charge. We've got to keep track and make sure everything gets done. It's not a problem, just make sure we know. The first aid kit is by the sink. If you get a minor cut or something, report that, but we've got the first aid kit right here. Now I showed you where the emergency stop button was there on the wall. That's fine. I want to point out a couple of other things, specifically about this machine. This is called the lathe. There's a couple of special safety comments about that. Well, I guess we're going to have to edit that out.
That's okay. That's okay.
All right. Here's the 3-jaw chuck. To operate this, put the handle in and turn it to grab whatever work piece you're putting in here. When you're done with the 3-jaw chuck, take the handle out. Never leave the handle in the chuck, because sometimes the machine can start by accident. If it does, it's either going to throw the chuck at a high speed out into the atmosphere, or it's going to come around and whack you in the hand, which hurts, or it's going to crash into the ways. Either way, it's bad. Just get in the habit of taking the chuck handle out every time you use the 3-jaw chuck. In addition, this machine, here's the start-stop handle down here. To start in the forward direction, you push it down. You pull it up to the center to stop it, and you pull it up to make it go in reverse. So it's got 3 positions. Now, being out here, it is possible to bump into it and have the machine start by accident. That's why whenever I'm doing something, especially with the 3-jaw, I'll push this red stop button in. That shuts the machine down. Now it won't start, no matter what. And I don't have to worry about accidentally bumping the handle. To reset this button, you just rotate it, and it pops out, and now the machine will run. This machine has a little trick to it. When we're sanding stuff, you want to be dragging the part so that the sanding belt is pushing away from the belt. If you're pushing it, in other words, if you're pushing up against the motion of the belt, then the belt can snatch it out of your hand. You don't want to do that. Always be dragging and not pushing. What I said was, the safe way to operate the machine is to be dragging your work and not pushing, where the operation of the belt tries to drag you in. With the milling machines, the main safety precaution there is to check that the vise is tight before you start the machine. If the vise is tight, there's not a lot that's going to go wrong with the machine. Occasionally you could break an end metal or a drill bit or something. So with the milling machine, the main safety precaution there is to make sure the vise is tight before you start the machine. As long as the vise is tight and you got a good grip on your work, then there's not a lot that's going to go wrong with that. One more thing. I should have found the dial caliper before we started. Now let's talk a little bit about shop practices. When we're making parts in here, making parts with dimensions that are usually down to 1/1000th of an inch in our measurements. Our usual practice is to make our tolerance plus or minus 2/1000ths of an inch. In other words, if you've got a part that's called out for 1 inch, if you're anywhere from 0.998 or up to 1.002, close enough. 2/1000ths of an inch is our tolerance. Let me show you how you measure that. All right, here I'm measuring a drill bit. And there we go, 1.1 there and then 49 thousandths here. This drill bit is 0.149. This tool is going to be a very useful tool. You're going to use it a lot. That's a dial caliper. You measure how big things are on the outside with these jaws. You can measure the inside of a hole with these jaws here. You can measure the depth of a hole with the tailpiece here. They all have the same readout here. It's a precision tool. Don't drop it on the floor. Don't use it as a toy. Don't use it to scratch your back. It's a precision tool. That tolerance that I told you is 0.002. Just to help you figure it out. I don't know how close you can get to this, Shay. There's a gap between those two jaws right there. That gap is 2/1000ths of an inch. That's the accuracy we're working to. If you take a hair off your head and measure that, that's going to be about 4/1000ths of an inch, give or take. Different people have different hair, but it's in that vicinity. So you can actually say that we're working to a tolerance of half the size of a hair. That's part of what makes our robot work. Things are accurate, things are straight, things are true. Most of our fasteners that we use on Team 88 are 1024. That's a number 10 screw, 24 threads per inch. Well, why do we use screw sizes in numbers? 10 is bigger than 8 and is smaller than 12, but what does 10 actually mean? Well, it's a long story, but the point is 10 is just the size. That's kind of like, why is a mile 5,280 feet? It just is. It's not supposed to be easy. You're going to drill a hole the way they later have to cut a thread in. It's going to be 0.149 of an inch. That's the tap drill size. If you want to drill a hole big enough to hold the screw, it's going to be 0.196. Sometimes I use a number 7 drill. That's going to be 0.201. That gives us an extra 0.005 of clearance. So there you go. We've talked a little bit about what it means to be on a team. We've talked a little bit about how to build a robot. We've talked a little bit about safety and shop practices. That's what's going on with Team 88. I want to introduce Mr. Spur, deeply involved with running a machine shop. We're going to be right at your shoulder while you're running these machines. That also means we don't want you to come in and start using the machines unless one of us is here. But that's for your safety. It's also to make sure you know what's going on with these machines. We can show you everything about them, and we'd love to take the time. If you want to spend the time, we will stay here as long as you want to make sure you know what's going on. Okay, that's it. Good luck, 88, and we'll see you on the flip side.